Hello, we are here in Chapter 4, Section 1, Angles and Radian Measure. Okay, this is typically our first real section in Math 137, which will be one of our kind of midterm classes that we kind of start with Math 138. Okay, so this is 4.1 angles and radian measures. So let's look at our objectives here. So for objectives, we'll have recognizing and using vocabulary of angles, using the degree measure, using radian measure, convert between degrees and radians. We're going to draw angles in standard position. We're going to find coterminal angles. We're going to find the length of a circular arc. And we're going to use linear and angular speed to describe motion on a circular path. Okay, so this is like 8 objectives. And what I'm going to do is I'm going to kind of divide this up into 2 videos because I think it will take us a while to do all 8 of these objectives. So I'm going to do the first 5 objectives in one video. So I'm going to stop on this first video at drawing angles in standard position. And the second video that we're going to have for this section is going to start at finding coterminal angles. Now, for this section as a whole, it's all about really finding just the vocabulary and using the correct formulas. Okay, so there's really not anything spectacular going on in this section. It's just kind of getting us ready to discuss trigonometry. Okay, so this is kind of the lay the groundwork to do that. A lot of this stuff is taught in high school geometry. Okay, some of it's intuitive and some of it's just basically formulas that you just have to use. So let's begin with our first objective about angles. Okay, what is an angle? An angle is formed by 2 rays that have a common endpoint. One ray is called the initial side and the other one's called the terminal side. So you have a ray BC and you have a ray BA that has they have a same endpoint. The blue one there is we call that one the initial side, and the red looking one is going to be the terminal side. Okay, so an angle in standard position if its vertex is at the origin of a rectangular coordinate system and its initial side lies on a positive x-axis. So remember the blue ray at the top? Well, that was the initial side. We're going to lay that one right on the positive x-axis, and both of them has the endpoint of the rays at the origin. So basically it's kind of like the red one is kind of like a propeller, but the blue one is the positive x-axis. That's the initial side. Alrighty, and the terminal side can lay in any quadrant that you wanted it. The first picture looks like it's going to be in the second quadrant, and the third one is the second picture is going to be in the third quadrant. But notice how the direction of the angle. The direction of the angle, like the first picture, is going counterclockwise. That ends up in the second quadrant. When angles do that, they're going to be positive. When you go clockwise, like the second picture indicates, it will be a negative angle. We'll talk about that a little bit more coming up. So, but the vertex is at the origin. All right, so let's go to the next one. When we see an initial side and the terminal side in place, there are 2 kinds of rotations that could be generated, the angle. Positive angles that I just discussed are generated by a counterclock rotation, and the angle alpha is positive. So the first picture. Negative angles are generated by a clockwise rotation, thus an angle theta is negative. An angle is called a quadrantal angle if its terminal sides lies on the x-axis or the y-axis, as illustrated here in this picture here. So you have this blue terminal side, and they call that one theta, and actually it's beta, and beta is an example of a quadrantal angle. So in this particular case, you skip basically 3 axes. You skip the positive x, positive y, the negative x, and go down to the negative y-axis. So that's going to be a positive angle. And we'll talk about a little bit more about that one a little bit later, but it's like 270 degrees. Okay. Now it's kind of interesting that you call this a quadrantal angle, because a quadrant is basically the four spaces right between the axes. And so a quadrant is those spaces, but when you have the terminal side that lies in between those quadrants, like in this case the negative y-axis, it's called a quadrantal angle. You would think a quadrantal angle would be an angle that lies in a quadrant, but that's not the way it works. Okay, so I always thought that was kind of interesting when you have a terminal side lies on an axis. It's called a quadrantal angle. You would think it would be called an axis angle or something like that, but it doesn't. They call it a quadrantal angle. I always found that interesting. Okay, so measuring angles using degrees. Okay, angles are measured by determining the amount of rotation from the initial side to the terminal side. A complete rotation of a circle is 360 degrees. And so an acute angle measures less than 90 degrees. Now, in geometry, that definition was okay because you didn't have negative angles. I think a more precise definition for this one, trigonometry, it would be an acute angle is an angle that measures between 0 and 90 degrees. Because if it says less than 90 degrees, well, negative 45 degrees is less than 90, right? So I think it should say between 0 and 90 degrees. This publisher just says less than 90. I think they should say less than 90, but more than 0. A right angle is an angle that measures 90 degrees. A lot of these definitions are like, I've seen these before. These are like geometry. Yeah, they are. That's where you may have seen these before, is high school geometry. An obtuse angle is an angle that measures more than 90, but less than 180. And a straight angle measures exactly 180 degrees. Okay, so those are what we call four special named angles. Measuring angles using radians. Okay, and angles whose vertex is in the center of the circle is called a central angle. The radian measure of any central angle in a circle is the length of the intercepted arc divided by the circle's radius. So beta equals the length of an intercepted arc divided by the radius. Our next slide that we're going to be seeing here is going to give us a little bit more detail of what a radian is. So degrees is one unit that we measure angles. Radians is another. Okay, and this is kind of like the introduction of that. Okay, all right. Now, definition of a radian. 1 radian is the measure of the central angle of a circle that intercepts an arc that has equal length of the radius of the arc. So if you look at the picture, the radius of that circle is r, but the length of that arc is also r. They have the same length. That's only going to happen that one time. Okay, so the angle that's formed by that central angle is 1 radian. Now, to be quite honest with you, 1 radian is approximately 57 degrees. Okay, and we'll see that a little bit later as you manipulate radians. But that's what 1 radian is. 1 radian is about 57 degrees, but you find it when the arc length and the radius has the same length. So if you remember what they said on the previous slide, beta is 1 radian is the length of the intercepted arc, and the radius, when you divide those numbers up, when does that equal 1? When they are the same. So the arc length, the length of the intercepted arc, and the radius, when they are the same number, like r, what's r divided by r? That's 1. So if we go back to the next slide here, see the arc length is r, the radius is r. When you divide those numbers up, that's 1. 1 radian. So radian measure, consider an arc of length s on a circle of the radius r. The measure of the central angle, theta is the intercepted arc, is measured by s divided by r, so radians. So that's just another way to write it as a formula. So theta is s divided by r. So if you have the arc length is 2 radiuses, then you'd have 2 radians. So that's the idea. Okay, Computing radian measure. Okay, so a central angle, theta, in a circle of radius 12 feet intercepts an arc of length 42 feet. What is the radian measure of theta? All right. So theta is S divided by R because S is the arc length and it's 42 feet and the radius is 12 feet. So you divide those out and you'll get 3.5. Notice the feet cancels. So the radian is the theta is measured in 3.5 radians. Now if you have a hard time figuring out what that basically means, 3.5 radians. Now remember what I said a while ago, 1 radian is about 57 degrees. So if you're having a hard time visualizing what this is basically meaning, multiply 3.5 times 57, and that'll tell you about how many degrees that's going to be. It's going to probably be an angle that is in the third quadrant. It's going to be more than 180. Less than 270, but more than 180 degrees. So basically, think of it this way. You have a circle. The radius is 12 feet, and you go around the circle, and the circle has an arc length of 42 feet. So you're going to end up in the third quadrant when that happens, when it measures 42 feet. But that angle that's formed by that is 3.5 radians. Okay? Now, using the basic relationship, pi radians is 180 degrees. This is the conversion between degrees and radians. So this is the biggest thing, is when somebody talks to you in degrees, and somebody else is talking about to you in radians, they could be talking about the same angle measure, but they'll be using different formulas or different notation. Okay, it's kind of like speaking another language. You know, somebody could say the same verbiage to you in French as they're saying it to you in English, exactly the same thing, but you won't. If you don't know but one language, you wouldn't know that. That's the same thing. Okay, this is basically a new language for a lot of people. But what it is, we know 180 degrees is halfway around the circle. Okay, because it's 360 degrees all the way around, right? So when you're talking about angles and degrees, that's 180 degrees. But that is the same thing as pi radians. Now what's pi? Pi is about 3.14 approximately. So halfway around is 3.14 radians. Now I want you to remember something. Remember a while ago when I said that 1 radian is about 57 degrees? Remember that? So if you have 1 radian is 57 degrees. What if you had 3 radians? Well, you'd multiply 3 times 57, right? So 3 radians would be approximately 171 to 172 degrees. Well, that's not quite 180, is it? So 180 degrees is pi radians. 3 radians is about 171, 172 degrees. Well, that 0.14 on the pi is that remaining 7 or 8 degrees that you have left. So 1 radian is 57 degrees, approximately. Pi radians, which is approximately 3.14, is 180 degrees. So that's what it is. So that's the relationship. That's the main relationship between what radians is and degrees. So as you could probably guess, if pi radians is 180 degrees, what's 2 pi? 2 pi's. Well, 1 pi is 180, 2 pi's is 360 degrees. So if you go all the way around the circle, it's 360 degrees or 2 pi radians. So that's the main connection between the two conversions. So to convert degrees to radians, we multiply by pi radians over 180. You're like, why can you do that? Well, because pi and 180 is the same thing, just different. It's just a different format. If you're going to convert radians to degrees, you multiply radians by 180 over pi, just the other way around. Okay? So let's look at another example. If we're going to convert each angle to degrees to radians, okay, so if you have 60 degrees, so we're going to multiply 60 times pi over 180, and the degrees would cancel, right? So you get 60 pi over 180. Now, 60 pi over 180 reduces to pi over 3 radians. So 60 degrees is the same thing as pi over 3 radians. Some of these things you almost need to just memorize, and that's one of them, because that's a special angle, and 60 degrees and pi over 3 radians is the same. Now it makes sense too, you think about it. You know, if you have 180 degrees, right, and that's the same thing as pi, what is 60 degrees? Well, it's a third of a half of a revolution, right? So it's 60 is a third of 180. Well, what's a third of pi? Pi over 3. So let's say that again. 60 degrees is 1/3 of 180 degrees. So what's 1/3 of pi? Pi over 3. So pi over 3 and 60 degrees are the same, since pi and 180 degrees is the same thing. Now let's do the 270 degrees. 270 degrees, multiply that by pi over 180, and you get 270 pi over 180, and that reduces to 3 pi over 2. And that makes sense too. And you think about it. You know, what's 180 degrees? Well, it's 180 degrees is pi radians. What's half of 180? 90. Yep. So what's 90 degrees? Same thing in radians. Well, it's half of pi. So 80 degrees, 180 degrees is the same thing as pi. So half of 180 is 90 degrees. 90 degrees is the same thing as pi over 2. That's the relationship between those two. So 90 degrees is the same thing as pi over 2. Now let's just do the multiples of those. What is the next multiple of 90? 180. What's the next multiple of 180? 270. Okay, now let's do the multiples of pi over 2. Pi over 2, 2 pi over 2, which is pi, and then another pi over 2 is 3 pi over 2. So 270 degrees is the same thing as 3 pi over 2. So we're talking about special angles here. So 270 degrees is the same thing as 3 pi over 2. Okay? Now, look at the third one. Negative 300 degrees. Now remember, the negative angle just means the direction it's going. So this is going clockwise. But it works the same. You multiply it by pi over 180, so you get negative 300 pi over 180, reduces down to negative 5 pi over 3 radians. So negative 300 degrees is the same thing as a negative 5 pi over 3. And so you might guess, what is 300 degrees? 300 degrees is the same thing as 5 pi over 3. Okay, so, and think about, another way to think about this one is, you remember 300 degrees. Okay, 300 degrees is just shy of 360 degrees, right? It's actually 60 degrees shy of that. Now, you remember what 60 degrees was? That was pi over 3, wasn't it? So pi over 3 is 60 degrees. If you go all the way around, it's 2 pi. But if you take just shy of that 60 degrees, it'd be 2 pi take away pi over 3, which is 5 pi over 3. So you can do this by formulas, or you can do it by relationships. So probably the best way when you're first learning this stuff is by the formula. But relationships is helpful as well. Like on part B, doing the multiples of 90 degrees, and then doing the multiples of pi over 2. It would be the same multiple. Okay, so it's neither here nor there how you do it, because a lot of these you're just going to memorize later on anyway. I mean, before it's all said and done, before we leave this semester, when you see 60 degrees, you're going to automatically think, oh, that's pi over 3. Or and vice versa. If you say pi over 3, oh, that's 60 degrees. So the difference between people who are really good at the conversion and people who are not, people who are fluent in a language like French, they don't have to convert. They do not have to convert the language into English to understand it. Okay? That you speak to them in French, someone who's fluent in French, they'll understand immediately what that is. Okay? But someone who's learning French and knows English, but they're learning French, what do they have to do when you give them the verbiage? Well, they have to convert it to a language that they know. So they convert French to English, then they understand. Okay? So, but someone who is fluent in the language, just understands immediately. They don't have to do any conversion. Okay? Same thing here. If somebody tells you, I have an angle that measures pi over 4 radians. Now, do you know what pi over 4 radians? I haven't discussed that one yet. Pi over 4 radians, do you know what that is? I do. It's 45 degrees. I didn't do any conversion. It's because I can visualize what that angle is in degrees or radians. It doesn't matter what that is. But someone who is not fluent in radians would have to know how to convert radians to degrees. And that is our next slide. So example 3, converting radians to degrees. So we have pi over 4 radians. So we're going to multiply that by 180 over pi radians. So the radians cancel, the pi's cancel. So you get 180 degrees over 4, which is 45 degrees. Okay? So pi over 4 radians is 45 degrees. Now, again, you can do this by relationships. Think about it this way. What's half of 180 degrees? 90 degrees. What's half of 90 degrees? 45 degrees. Now, let's do it in radians. What's half of pi? Pi over 2. What's half of pi over 2? Pi over 4. Let's do it again. Half of 180 degrees is 90 degrees. Half of 90 degrees is 45 degrees. Half of pi is pi over 2. Half of pi over 2 is pi over 4. So pi over 4 and 45 degrees are the same. I did half of pi, and then I took half of 180 twice. Okay, that's how it's, but some people can't do that. They're not visual like that, so they just think of the formulas. Pi over 4 is going to be another one of our special angles. So you'd be better off just as quickly as you can just to start memorizing all these special angles in this section. Negative 4 pi over 3, so we're going to multiply by 180 over pi. The pi's cancel, the radians cancel. 4 times 180 divided by 3. Now you can multiply the 4 times 180 and then divide by 3, or you can just divide 180 by 3 and get 60. And then 60 times 4 is 240 degrees, but it is negative. So the negative is just a directional thing. Part A went counterclockwise because it's a positive angle. B is going clockwise, 240 degrees. So the magnitude is the same. The measure of the angle is the same. It's the direction the angle is going is the only difference. Okay? So matter of fact, part A is in the first quadrant. Part B, the negative 240 degrees, is going to be in the second quadrant. Yep, the second quadrant. Because you're going clockwise. Because you go 0, negative 90, then negative 180, and then negative 240 ends up in the second quadrant. Okay? So negative 4 pi over 3 is equal to negative 240 degrees. So it's like saying negative 4 pi over 3 radians is in French, and negative 240 degrees is in English. So you're just doing a translation is all you're doing. You're just translating the words. Okay? 6 radians is a little different because 6 radians, multiply that by 180 over pi radians. The radians cancel. So 6 times 180 over pi. Because the pi didn't cancel this time, did it? So you get 6 times 180, which is 1,080 degrees, divided by pi. Whoops. And the thing is, since the pi's don't cancel, you're going to get a decimal. So you have to get your calculator out and divide 1,080, which is what 6 times 180 is, and then divide that by pi. You're going to end up with 343.8 degrees approximately. So that's the thing about converting radians to degrees sometimes. Sometimes the measure doesn't come out exact. See, part A and part B came out exact. Part A exactly 45 degrees, part B exactly negative 240 degrees. But a lot of times when the angle does not have a pi in it, like 6 radians, they don't say 6 pi, 6 radians. Now a lot of people are like, what is 6 radians? Remember what 1 radian is. 1 radian is about 57 degrees approximately. So 2 radians is that times 2, 3 radians is that times 3. Well, 6 radians is about 57 degrees times 3. Now remember, I said approximately 57 degrees. I didn't say exactly 57 degrees. So if you take that angle out 57 degrees, multiply it times 6, you're going to get in the ballpark of 343.8. You won't get exactly because I'm estimating at the very beginning anyway. Okay? All right. Now, drawing angles in standard position. Okay? The figure below illustrates that when the terminal side makes one full revolution, it forms an angle whose radian measure is 2 pi, which we discussed that already. Okay, and that would be your first picture. It forms an angle with radian measure of 2 pi. The figure shows the quadrantal angles formed by 3/4, 1/2, and 1/4 of a revolution. Now, that doesn't mean 3/4, 1/2, and 1/4 radians. That means just 3/4 of a revolution. So the first one is 3/4 of a revolution. And you're like, it is? Yep, because every axis represents 1/4 of a revolution. So the positive y-axis is 1/4 of a revolution. That's illustrated by the last picture there. 2/4, which is 1/2, is half of a revolution, and that's represented by the third picture there. And then 1/4, 1/4, and 1/4 is 3/4. So it's going to be the third axis that you intersect, and that's your second picture. So 3/4 of a revolution is 3 pi over 2 radians because it's 3/4 of 2 pi. If you multiply 3/4 times 2 pi, you get 3 pi over 2. The second one is 1/2 of a revolution, so it's 1/2 of 2 pi, which is pi radians. And then the first one is basically 1/4 of 2 pi. And 1/4 of 2 pi is 2 pi over 4, which is pi over 2. Okay, so that's just talking about the revolutions. All right. Drawing angles in standard position. Let's draw and label the angle in standard position. Negative pi over 4. Now remember, negative is the directional. That means it's going clockwise, right? Now what's pi over 4? Well, pi is half of a revolution. So 1/4 of a pi is going to be 1/4 of a half. Or you could also think of it as this, okay? The angle is negative. It is obtained by rotating the terminal side clockwise. So it's pi over 4 is 1/8 of the whole 2 pi, because 1/8 times 2 is pi over 4. So remember, 2 pi is one complete revolution. 1/8 of that is 1/8 of a revolution. And it looks like that picture in the red. So every 45 degrees, or every pi over 4 radians, whichever you want to call it, ends up either in halfway in between a quadrant or on a quadrantal angle itself. So negative pi over 4 ends up in the fourth quadrant. And remember, negative pi over 4 would be negative 45 degrees. But it's 1/8 of a revolution. 2 pi is a revolution. And since each quadrant, the whole thing is divided up into 4 quadrants, and if you divide the quadrants in half, then you have 8 sectors, in other words. And so that is 1/8 of a sector. Okay, next one. Example 5, drawing angles in standard position. This is just another one. 3 pi over 4. Okay, it's actually, this actually is a positive angle. The angle is negative. No, it's not. It's positive. I don't know why they put negative, but it should be positive. It is obtained by rotating the terminal. Actually, it should be counterclockwise, because I do not see a negative on that one. So 3 pi over 4 is equals to 3/8 times 2 pi. So we rotate the terminal side 3/8 of a revolution. And if you notice, they actually do that in the correct manner on the picture. They keep saying negative, but it should be positive because you're going counterclockwise. So 3/8, remember, an eighth divides a quadrant in half, so it should be 3/8 sectors. So it'll be 3 out of 8. And that splits the second quadrant in half. So the first quadrant has 2 sectors. This one is 3 sectors. So that's 3/8 of a revolution. Okay, let's do another one. Example 6. Drawing angles in standard position. Draw and label the standard position as -7 pi over 4. Now remember, this is another negative angle. It's obtained by rotating the terminal side clockwise because it's negative. So negative 7 pi over 4 is 7/8 of 2 pi. So basically it's going to be 7 sectors. So we rotate the terminal side 7/8 of a revolution. So it looks like this. Now remember, it's negative, right? So you're going clockwise. So every quadrant contains two eighths, basically, 2/8 of a sector. So 2/8, 2/8, 2/8, that ends up the positive y-axis. So that's 6/8, 2/8, 4/8, 6/8, and then that 1/8 more that's in the first quadrant makes 7/8. So that's going to be a negative 7 pi over 4. All righty. All right, let's look at another example. I think this is our last example here. We're going to draw another angle in standard position. We're going to do 13 pi over 4. Okay. So this angle is actually positive again. I think they're kind of stuck on the negative one. It is obtained by rotating the angle. Actually should be counterclockwise because it's positive. 13 pi over 4 is going to be 13 pi over 8 times 2. I think they did a lot of cutting and pasting on this thing, so it should be positive on those. So 13 over 8 times 2 pi. Okay, so that is equals to, we rotate the terminal side 13/8 of a revolution. Now you're like, well, wait a minute, one revolution is one revolution, so it's 8 over 8. So this is going to go past one revolution, and you're right. So if you look at the angle, okay, and it's going to be 13 over 8 revolutions, and remember you start on the initial side, go through the first quadrant, that's 2/8, another quadrant is another 2/8, another quadrant 6/8, and then back to where you started is 8/8, right? Well, let's keep going. If you keep going around it again, that's going to be 10/8. Now you're up at the positive y-axis. Then 12/8 would be the negative x-axis. So we're almost there. So then one more eighth is 13/8, which ends up in the third quadrant. Now I kind of do this a little differently when I'm doing it myself. 13 pi over 4, I just count by quarters all the way across. Okay, so I just go by quarters. 1/8, 1/4, 2/4, 3/4, and then I'll just count to 13/4, and then I end up in the same place. So whichever you want, if you want to do it by revolutions, that's fine, or you can count it by the angle measure, which is fine as well. So 13 pi over 4 ends up in the third quadrant. It splits the quadrant in half. But keep in mind, the angle is actually more than 2 pi radians. It's actually more than 360 degrees, right? So it went all the way around and then some. So think about trigonometry. You know, in geometry, the angles basically measure from 0 to 360 degrees, okay? And you never really measure an angle that surpassed 360 degrees. Most of the time it was just between 0 and 180 degrees because you're dealing with triangles a lot. And now that we're dealing with circles, you can go around more than once, okay? So a lot of times your angle measure is more than 360 degrees, like this one. 13 pi over 4 exceeds 360 degrees quite a bit. So, okay? So I'm going to call this one done, okay? Now, I hope you're going through here and actually, doing all of the note-taking that you need to do on the examples, showing the pictures of it and everything else. But I will tell you, okay, this is a lot about formulas, okay, a lot of intuitive stuff that you've already learned in geometry. So I'm hoping this is kind of a review for a lot of it, but I'm also hoping that you can get that relationship between radian measure to degree measure and conversely backwards, okay, really quickly, because that's going to be a big deal, okay, because we don't want to sit here 3 weeks later after today and me still trying to explain to you what pi over 4 radians is, okay. Pi over 4 radians, 45 degrees. It's okay to kind of get those down now, but you've got to be able to convert from one angle to another angle, okay. A lot of people want to know, well, why are we have to learn a new way of measuring angles? Well, there's a lot of reasons for that, but the main reason I'm going to put forth right now is that when we have angles that supersede 360 degrees, that goes past 360 degrees. When you're measuring those angles in degrees, they can get to 4 digits and 5 digits very quickly. I mean, you think about it. If you go all the way around, one time it's 360 degrees. What if you go around again? Well, that's 720. Well, go around again. Well, it's going to be 720 plus 360. You know what that is off the top of your head? But then what if you go around again? Do you see my point? So when you go around 4 revolutions around a circle, what is that in degrees? It's a pretty good size angle. But what if you go around 4 revolutions if you measure in radians? Well, 1 revolution is 2 pi, right? What's 2 revolutions? Well, that would make 2 pi and 2 pi. That's 4 pi. What if you go around the revolution again? That's 6 pi. What if you go around again? That's 8 pi. See, that's the thing is when you're measuring radians, going around more than once is not that big of an angle. It's not that big of a deal. When you go around several times in degree measurement, you can get to 4 digits angles rather quickly. And you have to keep adding 360 to 360, 360, and that becomes very cumbersome after a while. So that's the reason I'm going to put 4th. There's other reasons for that, but I'm not going to talk about that right now. So, alrighty. But anyway, that concludes this video. If you have any questions on it, this is actually part 1. If I still didn't answer your questions, if you got started on your homework already, there is a part 2 to this video. So that might answer your questions from part 2. Okay, so if you watch that one. So I will see you there when we get there. Have a good day.